and south poles.
Cooper, stop.
What else has a north and a south pole?
The world.
The earth. The earth has a north. Did you know that, Cooper? The earth has a north and a south pole.
Yeah, like what I did was where I put right here. Like,
Did you know that magnets have the north and south pole?
yeah, that's where the magnets hook up with each other. Like other little things around is right here.
Yeah. What other little things? Tell me what those things are.
Autumn,
Leaves?
magnets, leaves.
Leaves do?
Sometimes like a certain kind of leaf thing.
No.
Paper clips.
No. Paper clips. Why paper clips?
They're metal.
Yeah.
What?
I haven't Why?
They're just not
Why?
atoms inside.
The atoms.
And a positive and negative.
Okay, because of positive and negative. You guys might want to write in your book that positive attracts to negative.
Because no, it said in the book that not all metal is.
Lane has made a very good point. He said he just read that not all metal is magnetized. It's not all magnetic. Right? Why? Tell me why. Read about it. Because it said in the book. Okay. All right. Everybody look at me. Since you're working hard on your books, I want to talk about now how the earth is like a giant magnet. It has its own magnetic field. I want to talk about a hypothesis that you're about to write in your book. Tell me how you think a compass works. What is a compass? Tell me.
A compass is.
Let Cooper finish.
A compass is like in a circle, and it has a north, south, east, and west on it with little arrows, and it has everything around it, and it tells directions. So like it shows you where you are. Like in case you don't have like sometimes in cars they have on their little
GPS thing.
A little GPS thing with north, south, northeast, or southwest or something. If you don't have that, you have a compass, and it tells you it has glass on it, so you can't like mess with it. And it has a couple little arrows inside that points where you were at.
Yeah.
And it has like magnets probably inside of it going around.
Perhaps.
Atoms and stuff like that.
Atoms.
Atoms. It uses the world's magnetic field.
A compass uses the world's magnetic fields. To find what? Polar. It finds north. So everybody turn to page 218. Yes. There's a whole bunch of them in. Everybody turn to page 218 and let's read. It's about science and history. Ready? Science can change the course of history. We've seen that lots and lots of times, haven't we? Which way to go? The first record of boats large enough to carry trade goods is around 3500 BC. The first navigators sailed close to shore and navigated by land, characteristics that they could see by day. Sailing at night was impossible. Eventually, sailors learned to find their way by using the position of the sun and stars. Using their knowledge of the heavens and the ocean currents, Vikings and Polynesians traveled remarkable distances far from the side of land. But what happened on cloudy nights? What do you think they do on cloudy nights?
Use a compass.
They didn't have a compass.
Or the earth.
Sometimes
the stars. No, they're stars.
Well, it's a cloudy night.
They could use the if they knew their way around so good, they could stay close to the by shore.
But they were far out, away from shore. What would they do on a cloudy night?
They probably stab each other.
Cooper, sorry. Well, he raises his hand so much, I was saying Cooper.
Would it be the wind
What,
currents?
Colin? Would it be what?
Wind currents?
Wind currents, perhaps. What? Tides, perhaps. Let's see. kissing rocks. Kissing rocks. The Chinese had discovered the solution more than 2,000 years ago. They found interesting rocks they called zuchi, loving stones. They're called loving stones because they like to kiss. What else do you know of that perhaps you put on your refrigerator that kiss? Magnets. These rocks contained magnetite, a mineral containing magnetic iron oxide. So everybody look at the illustration. That is a compass. The compass on the right was used by sailors during the 18th century. The compass on the left is a modern compass. Who's in the Boy Scouts? Or the Girl Scouts, for that matter?
I've never been in it.
Who's gone camping? Whose dad has a compass? Who's seen a compass? Excellent. Who has a compass in their house? Who's played with a compass?
I don't know for sure. I played with a toy one that was like
a toy one is perfect. Excellent.
But I don't know what it is.
So let's see.
Everyone in this class should raise their hand for seeing a compass because they don't want to speak.
Who's seen a compass in real life and not just on the page?
I don't
There
know.
we go.
I have one in my pocket.
She has one in her pocket.
Show us.
Let's see.
I don't have it on, but I have my phone in my pocket.
Christian downloaded a compass for me on my phone to show you guys as part of our thing today. Yes.
We were playing, when we were at Sunshine, and then when they gave out prizes,
Yes.
when we A's,
Yes.
my mom got my dad a compass.
Oh. Well, let's see what the Chinese realized about these kissing rocks. Ready, Darian? We're going to see what the Chinese learned about kissing rocks. The Chinese realized that they could use the magnetite to magnetize iron needles. When the needles floated in water, they always pointed north and south. They had made the first compass. The Earth's magnetic field. Earth's iron core produces a magnetic field similar to the field of a huge bar magnet. The compass needle rotates until its north and south poles point toward Earth's opposite magnetic poles, which are close to the geographic north and south poles. So whether it was clear or cloudy, the compass allowed sailors to travel great distances and return home to safety. Return home safely. Between the 13th and 19th centuries, there were many improvements to the compass. The ability to travel the seas opened trade between distant cultures. Goods and customs were exchanged, leading to the development of new ideas and tools. Knowing which way to go in the rain or shine opened up the world. So, the Earth is magnetic. It's a giant magnetic field. So here's the Earth and the north and the south, right?
Yes.
And it's magnet. So one is more positive, and one is negative. So whenever we know that positive and negative are attracted, so when you make an iron needle into a magnet, it turns so that its negative is attracted to the positive and its positive is attracted to the negative. Let's everybody open up their book and write their flip book, just a sec, and write your hypothesis, which is what? What's a hypothesis? Your best guess. Write your best guess, because we're about to make a compass.
For what?
To see if, your best guess, to see if Mrs. Newell can really make a compass out of a needle and some water and a piece of egg carton. Write your hypothesis.
I watch Man vs. Wild.
You watch Man vs. Wild in any one of your pages. In any one of your pages. How can you start that? I think there's no way a compass can be made out of a needle. A needle. I think you're right. Compasses do not make That's excellent. Wow. Yes, you may. Yes.
I say yes.
Mercedes is going to write hypothesis on the board. We're going to write back here, so we're going to have space to write, okay?
Oh yeah, that's a hard word.
Oh my goodness. So,
I say yes.
okay. What?
So right here.
Yes.
What do we title it?
You can title it Compass.
Putting it on Earth is like two magnets because I already said that compass on my.
Okay, whatever works. There's no pot. Yeah. That's good. Okay, here we go. Everybody turn your attention
To the board.
to the board. Okay? I'm not sure if light on or light off is going to make it better, so we'll try it both ways. Here is a needle, a common needle. Does everybody see that?
Yes.
Yep. Here is a powerful magnet.
Whoa.
Now, this magnet is pretty powerful. I got it out of the, do you remember reading in your book about how speakers use magnets?
Yes, ma'am.
This is a magnet from a speaker.
Oh wow.
Yeah, and it's so powerful that I always put it on my refrigerator, but I can't pull it off of my refrigerator to put something underneath it. So I had to attach this piece of ribbon to it so that I can grab the ribbon and pull it off the freezer. Yes.
Have you ever had to, like, you've had a magnet on the refrigerator, you can't get it off, so you have to slide it to the edge?
Yes,
That's what I have
that's
to
a
do.
strong. So this is what we're going to do. We're going to put the needle on there, which is not magnetic. Do you see how I did that? And I'm going to rub it.
Like a lamp.
I'm going to rub it like a lamp. That's right, Darian, like a lamp. So we're rubbing it, rubbing it. Ouch. Don't poke yourself. For crying out loud, that hurts.
That would hurt.
So let's see. Now, hopefully it's magnetized. Now, I cut out of an egg carton this little piece of styrofoam so that my needle would float. And now I'm going to put it in the water. And now,
Now we need a real compass so we
I'm about to put one up. Very good, Jordan. So let's see. Which way is north? Can anybody see the compass?
Oh. Yes.
Is that needle pointing about in the same direction?
Yes.
It sure is. Did we just make a compass out of a needle?
Yes.
That's crazy.
I knew it.
You guys are geniuses. That's how they traveled. That's because this needle is now a magnet, and it is attracted to the north and south poles.
Is it a magnet forever now or no?
It is a magnet, not forever. It's a temporary magnet. Just like yesterday, when we had electricity go into our nail, it was a magnet. As soon as we pulled the battery, the wires off the battery terminals, it was no longer a magnet, and those nails dropped. Okay? Magnets, that's awesome. Okay, now, I'm going to turn back on the lights. Okay? And I want you to listen. I've got some questions here that I want you to answer. I want you to write down your observations. You can write down what I did and what happened. Those are your observations. Write down what I did and what happened. What did I do first?
So what
Wait,
would
what?
we label this thing?
Compass
It would be compass. What did I do first?
Get a bowl of water.
I got a bowl of water.
Put it there, and then you got the magnet. So it's the magnet. Put the needle on the magnet.
That's right, I put
and
the
rubbed
needle
it,
on the magnet and
And then
rubbed
you got
it.
that piece of egg cart and put the needle inside the egg cart and then put it in the water and let it do its thing and get the phone out with the magnet.
You tell me what thing was. You said let it do its thing. What did it do?
Let it do its magnetic pulse around.
It spun around till it got in line, positive and negative, with the poles of the earth, huh? So yeah, what? No, tell me, Levi, what?
I just figured it out.
You figured it out. I cut a piece of egg carton. You guys could do this at home. You could wow your parents.
Impress them.
You could.
Set your numbers down.
Okay. When you're done writing down your observations of what happened, then and how I did it, draw a picture. Draw a picture of what you see. Oh gosh. Devin wasn't here, so I'm going to do it one more time, okay? Yes, please. Yes.
If you look at it right now,
Yes.
the one on your phone keeps on changing, and I bet if we leave it in there for long enough, it'll probably turn a little bit.
You think so? That is an excellent observation that I would like you to write down, Kelby.
I think we should see what happens when we put the magnetized needle next to the actual to your phone.
Well, it has to have the water in order to be able to move on its own. So, Devin, here's a bowl of water, okay? We're going to do it one more time, okay, you guys?
Okay.
And this is a magnet, Devin. See this strong magnet?
Yep.
And then this is a needle. Do you see the needle? Okay. I'm going to put the needle on the magnet, and I'm going to rub it a little bit. Just like this. Let me see.
Is it just like a needle, like a sewing needle?
Yep, it's just a sewing needle. Kelby, I'll bring it over to you so you can see if you want.
Does it have to be that strong of a magnet, or can it just be a regular magnet?
You know what? That is a great question. I don't know. So we should try it with a not so strong magnet and then a strong magnet. In fact, I have another needle, and look at Mrs. Turnbow has magnets on her board. So we will get a not as strong magnet and try it. Good job, good idea. Okay, here we go. We're rubbing it, Devin. And then I take the needle off the magnet. Now look, Devin, here's a little piece of, do you see this blue thing? It's actually just a piece of styrofoam I cut out of an egg carton. Because they wanted me to find a cork. I don't have I don't drink wine. So here we go. I drop that in the water, Devin. And what's it do? Let's see. It's spinning around.
That's so cool.
You see, Devin, over here is a compass from my phone. Do you see that? And look at here, Devin. Is the needle, let's see if I can get it out to where you can see it better. Is the needle and the compass, they're going the same direction, aren't they?
Is the water out of it, or is it?
The water's inside the thing. Do you see how it's spinning around? Oh, it can't touch the side. No, it's not under the water. Come up here, Devin. Look. Come up here and look. Walk right around. See? When it gets to the edge, though, you guys, it touches, and that messes it up. See, it's floating on top of the water. See how it's pointing the same direction when it's not touching the edge? See that? It's pointing north and south. Pretty cool, huh? So go draw a picture about that. Okay, I'm getting another needle out, and we'll try Estrella's hypothesis. Her best guess. I'm going to see, here's another needle that has not been magnetized. I'm about to magnetize. Oh, not on that. Thank you. Woo, thank you.
Don't poke
For me. So here's a magnet that's not quite as strong. And I'm putting the needle on there. I'm going to rub it back and forth.
Don't stab yourself.
Don't stab yourself.
You don't want blood up here?
No,
blood
it
in
just makes me want to faint.
Okay, here we go. Tell me when you think that's ready, Estrella. Estrella says she thinks it's ready. And I'm putting the needle in the little floater guy. Let's see. Let's see what we got here. Let me spin it so that it has to pull itself around. Yep, it's pulling itself around. So, look at there. The needle becomes magnetized even with a less strong magnet. That is something you should write down. Yes.